it's a good thing that relates to my research area, really, luckily, because I'm a neuroscience related to my PhD, postdoc, everything, whole life is neuroscience, and mainly this lecture, action potential. Most of the time I work with sodium channels, calcium channel, patch climb, and lipid bilayer, single molecule electrophysiology. So whole lecture, please be free to ask any question. I will be glad, because sometimes students tell me new things, really. So I will be glad if you ask difficult questions, so that we understand the concept. The topic is neurons and their potentials. What it means? We will not be given much time because we have to finish now. First of all, you will know what are the objectives of this lecture. You have the slides.
Yes.
I think maybe all people did bring, but you can see here.
Yes.
Is it? Can you see that?
Yes.
No problem?
Yeah.
Leader and others, let me know anytime some problem, some difficult words. If I'm talking too fast, you do not understand, you must tell me, teacher, stop me. Because the major purpose is that you understand.
Yes.
If I'm talking too much, there's no need of that. Maafi darura. Okay, so, but the real purpose, real objective, is the you get objective. The real objective is you get the concept of what I'm saying. And if you do not understand my English, I'm trying to speak easy, right? But still, who knows? It is easy for me. So please tell me, I never mind. You know that. You already know I never. I become more happy if you ask and tell me, teacher, you talked whole lecture, didn't understand anything. Oh, I will not be angry. I will be happy anybody who told me. How I will know that? You know that? So the objectives are, number one, you know that one is neuron. This is, you know that. This is neuron body. You say neuron body, this is soma, right? And this is axon. These are dendrites, this is soma, DNA is there. Soma is the whole, this part. I mean the cell body is also called as soma. It's a nice name. I think the girls should have soma name. Maybe, I don't know. But anyways, you can now remember. Now you will remember, definitely. So, soma and cell body, same thing, right? Soma has dendrites. Dendrites take the message. They take the message from the vicinity. I mean, the people who are around other neuron, they take the message. And what is the purpose of axon? They transmit the message, maybe from here to the legs. They transmit. So this is the basic difference. The dendrites take the message and give to whom? Soma. And axons take the message from soma. Cell body is very important. And convey means spread, conduct that message or that impulse to periphery. بعيد. Soma is قريب. Now axon is going toward the بعيد. Okay, so you got this point or not?
Yes.
Now, this flow is very important. Sometimes this flow is in this direction, sometimes this flow is in this direction. I mean, if from the body, skin, muscles, this is the body. Whether some substance is traveling, this is exoplasm, fluid. It is protoplasm. If fluid is present in the nerve cell, exoplasm. If it is in the muscle, myoplasm. So it is protoplasm, okay? You can say cytoplasm, whatever. So this is a tube. Inside it is the fluid is called as exoplasm. Is that clear? So this is a fluid. So the conduction passes by two ways. Electrically, outside. Chemically, inside. So we say electrochemical. What we say? Electrochemical. So the impulse is electrochemical. Now, the flow may go from soma, cell body, toward the human body, periphery, skin, etc. Or the message can go from the body to the. This is very important. You know why? Because there are many viral diseases. You know why viruses, what they do? They remain in the neurons for some time, or they remain here sometime. They hide. And this is the reason sometimes symptoms do not appear, they hide. And then they travel. They take the advantage. No any fear. They go into the bus and go and don't give the money, you know? So I'm joking. So it goes from here to here. See, the infection is present, but very silently goes up till here. Meanwhile, no manifestation, no symptoms. But when it appears here, he becomes boss. He says, talks with this boy, who you are. He says, I am the leader. I'm coordinator. Leader. So he says, I'm the boss. That's go. You are so powerful. You don't know me. You don't know. I am virus. I am cancer. So, but they still say people he calls, some dangerous person. Again he gives more and sits here. His DNA comes. Now it means I'm just telling exoplasmic flow and transport is how much important.
Yes.
You can imagine your pathology, your diseases relate to how from the body the organism goes up to the brain. Poliomyelitis, polio, many viruses, many other toxins, and how the some of the things, mitochondria, some important acetylcholine, and those they go from the brain. They are formed here. And they go outside into the body. I mean, they are very important. So physiology and pathophysiology both are related to exoplasmic flow or axonal flow. Okay, axonal flow or exoplasmic flow, axonal transport or exoplasmic transport. Okay. Now, so the first objective is you must know what is orthograde and retrograde. Orthograde means the transport from the brain. It is also called as anterograde. Okay, you will see it. I will not say anything outside the lecture. In the next page. So if the flow, something flows from here to at the body, it is orthograde. Okay? If something flows from the body skin to the neuron body, it is
Retrograde.
good, you got it. So, but they need some proteins. They are called as molecular motors. What they are called as? The word is molecular. It is not molecular. Okay? It's good to change, because I was there in North America for a long time. So it's good to set the pronunciation. So this is the molecular machine. Machine means protein. The single molecule is called as protein, the machine. Molecule is a big universe. It can do anything. It can help. So the kinesin, and there is another, we will discuss more because it's boring for you. First I tell you. There are two proteins. One protein takes the cargo, all the things, transport to here. And there is another protein, motor, that brings things from here to here. You got it or not?
Yes.
Okay, so we will explain, these are objectives. Now how action potential occurs, excitation. And how the conduction of action potential. One thing is the production of action potential, depolarization, repolarization. But it flows from one place to other. This is called as conduction of action. Formation or development of action potential and propagation or conduction of action. Is it clear?
Yes.
These are two things. So purpose of the formation of action potential means impulse. To conduct this impulse, like if something comes under my, there is some dangerous thing under my feet, how I will know? By conduction. Only the production of action potential here is not enough. This action potential should travel up till the central nervous system. So traveling, conduction, propagation is very important. Clear or not?
Yeah.
Okay. So this is another objective. And describe the structure of the whole sodium channels. Now then, how the action potential occurs, depolarization, repolarization, all those. And what is the difference of the propagation of action? When it's action potential, what it means? Impulse, message, in electrical form. Is it clear or not? When I say action potential, it means message. It is in the form of
electrical form. And if the fiber is myelinated, how it will travel? Fast,
Faster.
slow, but you will discuss. If it is unmyelinated, so these were the objectives. Now we start the lecture. Outline. Simple. Axonal transport, excitability, propagation, okay, the same things. Now this is, tell me if you do not understand, I have explained you. So, I come to the second paragraph because first is we explained. The second paragraph is, can you see there? If you find any problem, tell me, okay? So the cell body, from, if something goes from the cell body to the body, skin, etc., it is called as, it is also called as anterograde or ortho. How you will remember? Antero and ortho, A and O come first. R comes after that. So A and O goes from soma to the, and R in alphabetical, A, B, C, D, R goes last, retrograde goes opposite. Just to remember, okay? Otherwise sometimes it's difficult, you can do mistakes. So nerve terminals to cell body. If something goes from the body, skin, nerve terminal toward the soma, then it will be called as the figure is there. I think figure is very small, but when you go home, you make it big. It's simple, whatever I taught you. In the next slide, you will get it. Molecular motors. Now tell me what these are. I told you there are two proteins. One is kinesin, and other is dinectin complex. So one is involved in anterograde, from the soma, and the other is from the body to soma. Okay, clear? I think there is no anything to understand. Is it clear or not?
Yes.
You should tell me, please. No need of hesitation. You quickly say, stand up, whatever teacher, explain again. Okay. Now there are some disorders. We will explain later. But most of the disorders in axonal transport relate to degeneration. You know?
Yes.
Nerves are degenerate. They die. They first get injured. Injury occurs. And the nerve cells, axons are injured. And they die. What will be the result? Mostly the result is memory is gone. We don't know what we did 1 hour before. I was talking with you, and when I come, I say, no, I didn't see you. So the dementia. So this is Alzheimer's disease. Now the other is mostly when injuries occur, we do work with trembling, you know. So I think Muhammad Ali,
Yes.
Muhammad Ali, the boxer, he got this. So Parkinson's disease. So why these occur? Because the nervous system damage occurs, or death of the cell occurs. So how to store memory? Dementia occurs. Dementia, memory loss, memory. I don't remember. I met with you, and when you come to me, I said, no, I didn't see you for the last 1 year. Oh, you met me 10 minutes before, okay? Alone, you discussed in detail a question and all. So this is, it happens usually a little bit, but if you do not remember that who's your mother, father, so many things. Dementia is a little more complex, don't think simple things. We forget usually in our daily life many things, but dementia is more, this Alzheimer's. So Alzheimer's disease, Parkinson's disease, and mostly the motor neuron diseases. So motor cells, they are injured, they die. So degenerative disorders occur if the axonal transport is not proper. Who does this? These viruses, toxins, other diseases, or if transportation from the brain, some important neurotransmitter does not, excitatory or inhibitory neurotransmitters are not available here. So there is some problem, maybe there is another problem, maybe there is a third problem. Due to that it happens, but whatever the axonal transport is disturbed. Is it clear?
Yes.
Okay, now anterograde transport, I quickly read it because I already have told you. During the reactivation from latency, what it means? You know the viruses, they remain latent, hiding. When they become active, they were sometime active, again active. Now what they do? They from for example, herpes simplex virus, herpes virus. What they do? They use anterograde. They use anterograde transport mechanism where for example, in the peripheral nervous system. I mean, here, when the nerves come out, they make sometime a set of neurons outside the central nervous system. This ganglia is not in the spinal cord. The nerves come out and they make collection of nerves. And this is the reason we say peripheral nervous system. So don't think that the neurons are the soma. This is only present in brain spinal cord. No. It is present also in the ganglia. Similarly in the stomach. I mean, the local brain, you can say. Real neurons, and they are controlled by the brain. Okay? So that we call peripheral nervous system. We do not include in central nervous system. Right? Central nervous system means brain and spinal cord. So the herpes simplex virus uses anterograde transport mechanism now he is present in the nerve cells. Okay? Soma in the peripheral nervous system. Now from soma it goes into the body. When it reaches the body, where it goes in the skin, in mucosa, and then it subsequently affects and disease fully appears. Did you get it?
Yes.
So for the virus, this virus, herpes simplex virus, virus travels anterogradely. Okay, or ortho. So both are terms are correct. This page is okay or not?
Yes.
Clear, children? Far away. Huh? Good? Okay. Yes. Question?
Which virus will actually have the herpes used?
Actually, they are present. They are very dangerous. But believe me, they do ehtiyat. Ehtiyat doesn't. See, they are very, very big, dangerous things. But you know, they very slowly destroy our body. If they know very well. I'm joking. I mean, they have the immune system, and possibility they feel that maybe people will kill us, and there is possibility. Our cells have many things, many secrets, asrar. So this is the reason their parents told them in their system it is there, because if the virus already went over there, the second time it goes, saw the manifestations, my forefathers, so all those things are there. Our body, meanwhile, Pasteur, immunization, what Pasteur discovered, our body prepares the things against those viruses. So virus very silently goes, remains in the hidden form, okay, and when it becomes activated, when the virus is sure that my enemies have no power, he creates problems. He first people fight with each other because the brain of the people, they become mad when he injects some of the things, cut maybe the ears and maybe the cuts here. I'm joking. So our people become mad. Oh, they quarrel with each other. He laughs. He laughs very much. Good. This is his plan. So you should also use this. This is the reason we have been told to help others, not to disturb others. Allah. So not to create any problem for others. So these things from physiology you should get lessons of. When the people quarrel, they lose their energy or many things, and at the end, what is your question? He's silently laughing, At the end, one kick and finish. So this is what is called as during the reactivation from latency. Silent period. Reactivated. You know how he reactivated. Okay, this page is clear? Because we do not have much time really. Now, a little bit detail. You can see anterograde from soma to the body. From soma, direction is from soma, anterograde. Okay? Clear or not?
Yes.
But this anterograde is helped by kinesin. Can you see kinesin? Kinesin, this is kinesin. See how the kinesin is helping. And they are kinesin and they are taking the cargo. So this is the kinesin actually serves the anterograde cargo. It serves as cargo. It takes the material and put inside and bring from the soma to the body. Did you get it? Now see from there. These long lines are tubules, microtubules. See those microtubules. You can see the sign microtubules. and mitochondria, all those. Now this will go, long line is microtubule. So with the help of they attach with the microtubules, and this, see the kinesin, how it's attached, see that, how it's attached, and they go toward the body. Yes?
So what's the cargo?
Cargo means the things. For example, anything that is excitability. For example, anything that is needed in the body, right? Anything that is needed in the skin, something, mitochondrial substances, some ribosomal, whatever. These are, they are brought with the kinesin. So kinesin is the motor. Motor means motor that brings the things, activity, what you say, sugar, that performs sugar. So which thing is there for sugar? Means the substances to be flowed. See that synthesis and all the vesicles and proteins, they go from the soma and to the ending and then the body. Is it clear? Yeah. Now the opposite is retrograde. See where is retrograde? Now you can see here it's written dineptin complex. This is retrograde. They see the shape. You can see the shape over there. It attached with the microtubule. Can you see that? Attached microtubule? Over there. That is attached. Like two ears. Can you see that picture?
Yes.
And now see that from the body it go to the for example mitochondria, whatever, it is brought to the soma. Are you understanding or not?
Yes.
I already told you what is the anterograde and the retrograde, but little detail. So the anterograde cargo is there, retrograde cargo is there, neurofilaments, neurotropic factors, microtubules, mitochondria, all those. So the simple is, one way is to bring the material, important material from the soma to the body, skin, etc. And sometimes from the body things are brought to the neuron body. Is that clear?
Yes.
Now you study more, and if you find any problem, you can you will be having my email. You can take from leader. You can email me. But short, only once half sentence. I will reply half. I mean quickly, one by one question. If you write 10 questions, sometimes I become lazy. You know. So the best is 1 or 2 questions at one time, and you can arise. Really, this is the best, day and night. You study even before examination. You tell me you didn't understand. Okay, so this page is done. Now, retrograde transport. I'm reading because I explained some neurotropic viruses. Those viruses that affect the nervous system. Those viruses that affect on the neuron. Okay, neurotropic viruses. For example, poliomyelitis, herpes, and rabies, and some toxins. They enter the peripheral nervous system and ascend to infect the cell body. Now see, they go from the body to the brain, cell body, and hence delay between infection and onset of the symptoms, and tetanus toxin is transported also. Very dangerous, you know that tetanus, you take the injection, you know, when you sometime are going get injury, you should quickly get that injection, you know, because this toxin will go to your brain, retrograde. Okay, is it clear? I think this is clear. If you feel problem, you must tell me now or later or any time before examination. Now this is the interactive lecture. So at this time, I will say you to raise question because this one topic is finished. And now the remaining is you studied in first year action potential. So any question? I think that was good question. You raised before that, mashallah. Very good question. And I think it was simple, okay? So I carry on, right? And maybe at some other stage you can think, relate. Now, excitability, you remember lipid bilayer? Yes. It is over there. Lipid bilayer means two layers. I think you remember. You remember or not?
Yes.
So, one layer and second layer. There are 2 layers, right? And in between somewhere is a protein hole. This is called as ion channel or pore. Because pore are formed by protein. Lipid cannot make. We cannot go and eat it. This is my research area. Right now I'm doing much work in this lipid bilayer, liposomes, and we say reconstituting protein. When we put the protein in it, usually initially we take a lipid drop, very droplet. There are procedures in the lipid plan, lipid bilayer. Then we add protein. We add in a very specific way that it makes ion channel. It's very interesting. But with the time you will know it when you will be, if any of you will go in this area. When ion channel is made there, then we put the ions here, inside and outside. We make inside single molecule, the inside and outside. So calcium flows. How it flows, out to in, into out, then we record with the electrophysiological spectrum. Single molecule recording. You know, the person who discovered got Nobel Prize. Nyer, a German scientist in 70s, he discovered patch clamp. Before that was voltage clamp, whole cell. Whole cell, when you record the whole cell is voltage clamp. When it's a single molecule, interesting. People are doing too deep, not only single nowadays, really. So anyways, you got it, where is the protein, integral protein, peripheral proteins, you can read all that. You know the extracellular glycoprotein. What means glycoprotein? When the carbohydrate combines with the protein, ion channel, glycoprotein. Glycolipid, when the carbohydrate outside combine with the lipid of the membrane. And similarly, globular protein, hydrophilic. Hydrophilic means because water is there. If this is extracellular, this is intra, both contain water. So this area is called as hydrophilic. Okay? Now here there is no water. So the people who do not like water, they go here. Hydrophobic. They have phobia. They repel water. These people attract. So according to that, this structure go out. See these circles? So hydrophilic and hydrophobic. So membrane bilayer has hydrophilic area. In between is hydrophobic. This is the way drugs work. When you will go in higher level pharmacology into medicine, you will study pharmacology. The mode of action of the drugs, there are two types of mode of action. Either the drug combined here does not go in if the drug is hydrophilic.
Yes.
And if it is hydrophobic, it will go here. And then it will work. I don't say more because we do not have much time, really. So, did you get it or not?
Yes.
Okay, good. The lipid bilayer, phospholipid protein, pumps, ion channels, you know that, right? Ion, sodium channel, potassium, potassium, all the ions go through those channels. Simple and facilitated diffusion. You know that, but it's simple and facilitated. If a substance go from higher to lower, after 12 o'clock, can I take 5 or 10 minutes?
Okay.
No problem?
No problem.
Jazakallah khair. Because really we lost the 10 minutes. So, now I will explain. So, if you have extracellular and intracellular fluid, from the extracellular fluid, if you have huge number of ions, for example, sodium. So, sodium are more outside, less in inside. Which direction sodium will flow? Outside? Good. This is called as diffusion. It is called as simple diffusion. Nobody helped. Like it was not a handicap. Like, no, nothing. Though nobody came to, please go with me. No. They went themselves from higher. So flow of the ions or substances, you can say, from their own higher concentration to their own lower concentration is called as diffusion. I think it's not written here. You study, in the next lecture, maybe I can give you in written form. Okay? Because now the new system is that we have to show the slides, we cannot bring too much material. So sometimes it becomes, so I will manage, don't worry, okay? But you got it, what is simple diffusion? You got it?
Yes.
Now, for example, if something like to go from higher to lower, but cannot go, maybe because of the size of the molecule is very big, then what to do? Higher to lower, but still because now there should be some helper, and we say carrier, who should facilitate. We also say facilitated diffusion. We also say carrier mediated. Why we say carrier mediated? Because carrier is very strange jinn or something. He touches that molecule was round and molecule become like thread. Very thread. Nature is changed. Oh, deep gin. Huh? And now it can go through the ion channel. Like it is so. Now this was the molecule. When it attached with a little carrier, it becomes like thread. See that chip? And very long, and it can go very easily. Did you get it or not?
Yes.
I'm not going in details, but facilitated means transport from higher to lower of some substance with the help of a carrier. Clear or not?
Clear.
Okay. So, ion pumps. When we will discuss the action potential, depolarization, we will discuss pumps, sodium potassium at that rate, and active transport. We will also discuss active transport, okay? And then simple diffusion, it's written. Simple diffusion through interstices of either simple diffusion occurs through these spaces or through ion channels. It depends the nature of the substance. Is it water, it is carbon dioxide, if it is soluble in lipid, it will go through here. Cholesterol, it will go through here. If it is insoluble in lipids, for example, water will go through the ion channel, pores. Okay? So it depends. If the substance is soluble in lipids, go through lipid, they do not have any problem. Their own relatives. They go through anywhere. This is if you study the lipid nature, lipid substances can go through the stomach of the liver, the heart of the liver. Oh, you understand? I'm joking. Huh? Yeah. Okay, so they can go anywhere, they can wander. This is their universe. But if it is not lipid bilayer, no. Then Allah Kareem has made another channel, pore. They can go through the pores. Special pores. Sodium can go through. Sodium pore, potassium pore, chloride, calcium, many others. And specification. And according to that, the diversity. So the many functions are. So many functions are made by a large number of ion channels. Similarly, you study neurotransmitters, a large number of new excitatory inhibitory. So variety of excitatory inhibitory function, and the mixing also made many functions. Similarly, ion channels made many functions, thousands and thousands. So this is the way bodies specialize from amoeba, even virus to higher level, and in human is the very most well organized, and particularly your brain, other parts of body. So this picture is okay. Yes. Hydrophobic surface. I think it's easy. You study it and it's okay. Now, composition of the cell. One, we say intracellular and extracellular. I think in first year you know what is intracellular, what is extracellular. Clear or not?
Clear.
Okay. See here, intracellular is sodium. How much inside the cell? Around 10, 50. Outside it is 140, 50. You remember? So, and potassium is more inside, 140, 50, and outside is maybe 5 or 10. Similarly, chloride is more in the outside, and proteins are very big mountains. They create hydrostatic pressure inside the cell. So those proteins are very important, and these are the proteins when depolarization occurs. The sodium goes, and who says? They just say, "Son, I will the catch." Oh, leave me. It's enough, but they don't leave. They don't. No. For 1 minute, for 2 minutes, they don't leave me. You know, depolarization continues. This is the reason. And repolarization, before occurrence of repolarization, it becomes so bad situation that the proteins are negative. Sodium can attach with the chloride, but before attaching chloride, the very big dangerous sodium is. But they say chloride go there, and they are also negative. Catch them. Oh, sodium says no. I have to bind with chloride. My partner, no partner. You have to say. There is hegma, and for some time sodium cannot go anywhere. So he conveys somewhere message. Message means the environment gets a message: positivity, negativity. His other companion, what is his name? Potassium. Oh, brother potassium, my friend potassium, I'm in a very bad condition. Big mountains caught me. Okay, I will sacrifice for you. What you will do? I will do repolarization. Oh, really? So potassium go out. You know what? Potassium repolarize. Who does the repolarization? Potassium. When potassium too much positive go outside, inside too much negativity, and the mountains becomes too worried. and they become mad, and sodium quickly goes up, and simply goes and requests the pump. Even pump takes this and bring out sodium. Sodium go it is own residence outside, and potassium there is another pump. It brings potassium inside. So both are living in their residence, but meanwhile they met with the enemies. Who were the enemies? The big mountains. So this is the delay. This is the reason when sodium ran inside, more and more sodium. Nobody knows what is going to happen. There are many thieves or very enemies, and they catch sodium, and sodium then it means the negativity remains inside. Negativity remains. But the time, not the day, the time, millisecond, the potassium goes out, the changes occur in the protein. Too much negativity affects the negative protein. Now protein does not, it repels, and so the sodium is released, and thank God, sodium says, thank God, I came in time. And potassium, potassium, are you okay? Sodium, potassium talk with each other. I'm joking, okay? You got it or not?
Yes.
This is the beautiful story and many stories. So this is written here. Now, how many ion channels are there? I said sodium, potassium, calcium, magnesium, but actually this is a structural way of classifying the channels. No, the physiological, the passive channel. Passive channels are the leaky channels. At the end of the repolarization, some more potassium goes. It is not the potassium channel. You know that? The people who discovered sodium potassium channel in 1950s, 60s and got Nobel Prize, Hodgkin, Descartes, all those people, very big scientists, they invented a third channel. They said, no, it's not only sodium and potassium channel. We need another potassium channel, and they named it leaky potassium channel. It is not potassium channel. No, it's not potassium channel. Leaky means due to that channel, when it opens, more potassium goes out. Because the physiologists are mostly philosophers. They think, they do experiment, but besides experiment, the most important thing is we should think, we should relate the things with each other. Like Einstein never did any experiment. He just stood there and thinking that. They did much work, but best work than any best researcher, better than that. So they concluded, no, how potassium and stuff potassium. So it's written leaky potassium. So passive channel means when the ions go from higher to lower concentration. Okay? And the channel opens without any mediation. No need of current, no need of any ligand. They can open anytime when the ions are higher. Did you get it? These are not the active channels, these are passive channels. And they are involved in diffusion. You understand? Simple diffusion.
Yes.
Diffusion means passive transport. And active transport is opposite. Active transport means from lower to higher. From low, and we need pump. Sodium pump. Who brings the sodium from in? To get rid from enemies? Sodium pump. Who brought the potassium from out to in? Potassium pump. We say sodium potassium pump. The Hodgkin who discovered they didn't know that what this pump is. They assumed just that. Now later, like maybe 30-40 years before, we precisely discovered people that it is an enzyme. See that? And the enzyme is sodium potassium ATPase that is present in the liver. It has two heads, like snake, two heads. Sodium and potassium. So sodium, they pump, it brings sodium out, potassium. But you can think there are two pumps or one whatever. Okay? So did you get it? It's enzyme. So enzyme is it's a protein. Enzyme is okay. So number two is chemical gated channels. What these are? Now they are entirely different. You try to bring higher level of sodium, whatever you do, sodium channel will not do. What type of sodium channel this is? No. It is not the passive sodium channel. It is ligand gated, chemically gated. So Alacrine has made the channels. If acetylcholine will come, it will open. If GABA will come, the chloride channel will open. If acetylcholine will come, sodium channel. So these sodium and chloride channels are not those passive channels. These are chemically gated channels. If chemical is going to attach, they will open. If it will not attach, they will not open. Did you get it or not?
Yes.
Okay.
And voltage gated, when change is voltage occurs,
Accumulation.
they open from minus 90, minus 80, minus 60, minus 50, they open. Voltage change. Mechanically gated. The last year I did some work in Australia. This was the first time I worked with mechanically gated channels. It's very interesting channels, and we cannot go in details really. It was around 2 months, very nice program. We used the liposomes. You know liposomes? Lipid bilayer is a big, liposome is very small. And these are small molecules. And we use patch lab recording the mechanical. Mechanical means outside the cell, like if you do like this, how I feel. Channels, mechanical channels. So these are when the channels that feel, that get they change the mechanical energy into electrical energy. Okay, we do like this, and the message goes to the brain. Message goes means it becomes action potential. So this becomes action potential. This is a force, mechanical force. It becomes the mechanical energy is changed to electrical, and it informs us.
Is this for the sensory?
Yes, exactly. The sense, nerve goes. The muscle, it goes through the nerve to inform the brain. Sensory. And the brain sends motor. So sensory and motor is a long story, but it happens in milliseconds. If when I do like this, I don't know what is happening. I know after a little time. Because sensory nerve will go, the people will have a majlis, see the time, what is Magan and Zaman and Magan and Las. So it will go to the brain, they will have a meeting, like you people do, so many meetings. Right? So they do a meeting and they decide, this synapse, 3 synapses, okay, now you go and tell them what is it, okay? If this side is burning, I go there, it burns, quickly I will go away. So this is motor that tells me I go away. It's very interesting. The system physiology or pathophysiology, very interesting processes. So did you get it? The types of the ion? Yes.
I did not get the chemical gate.
Chemical gated is simply, some are voltage gated. You got it? Voltage? Voltage is change in voltage. But if sometimes some channels you create voltage, they will not open. Their nature is different. And this is the reason. This was darura. So Allah Kareem, if for example all of the ion channels were voltage, the whole day we were dancing activity, nothing else. We were not able to do any activity. So Allah Kareem stabilized us. Not only movement, we should move very nicely. So we should have other channels also. They should not open due to the change in voltage. If it was going to change with the voltage, then whole day we were doing like that. There was no maqsad. Subhanallah. See, never kabir. So this is the reason some of the channels cannot be opened with the voltage change or any other change, except a messenger comes and says, Salaam alaikum, boys, how are you? And this is a message from the boss. Oh, come. Special key, they bring the key. Please, one moment. They go open the gate, please, and then they say, they talk with the boss, whatever. This is called as signaling. What is called as? Signaling. Nobody can enter. You can break the membrane. Some virus can break. Some whatever can change. The key. No, you can't. No, you have to go washroom. You have to go washroom. Give. You can go. No, don't. Someone has to go quickly, So, and maybe automatically you have. Nobody is seeing you go on the. Okay, so did you get it or not? Joe, this was your question. Is it clear? Yes. So now, if the function has to occur, excitatory substance will occur. If the function has to be inhibited, inhibitory chemical will occur. Inhibitory means don't do anything. Excitatory means do more. See the balance. Excitation, inhibition is the background of the medicine. Your whole medicine resides on this. Excitatory disorders, inhibitory, even cholesterol, lipids, proteins, whatever you add into your body, either you eat put iron and many other things and vitamins and foods.
Either they do function or inhibit certain function. So the diseases, if you have deficiency of certain vitamin, maybe you have excitatory disorder, and maybe you have inhibitory disorder, or mixing of these. So these channels are very important, and sometimes if they do not work, then excitatory inhibitory disorders occur. Diseases, pathology. We will talk more in the next year or some other time. Or you can come sometime. So now this topic is okay. These four are not. Students, 4 types of channels. Is some problem? Where is your colleague? Did he go out? No, he couldn't go out for washroom.
No, he is there.
No, he will not go washroom. No, it's not. No, maybe this can work. Yes, yes, come. Good. Scientist. Try. Maybe someone I did. Okay, what is resting membrane potential? Resting membrane potential. Resting means when sodium is not going into the membrane inside the cell. Okay, no problem. Okay, come. When sodium does not go, when there is no activity. Oh, okay, students, come on. Maybe 10 minutes, I will not take more. Yes, 10 minutes, we lost 10 minutes. Okay, so we will take. When sodium usually go in and it makes the message, right?
Yeah.
But when sodium does not go in, potassium does not go out, what it means? It means cell is resting. So this potential, usually minus 80, minus 90, minus 70, is called as resting membrane potential. You know that, okay? It's written here, and how it is established. Now see, who asked question? Chemical? Now I was waiting. See, sodium goes there, but it cannot enter. It cannot enter into the cell, right? But see, when a chemical binds over there, see, a chemical bound with the receptor. See that? Can you see that?
Yes.
Now, after binding of receptor, the doors were opened. Yes, sir. Please come in. Now, sodium goes in. Did you get this? This is the chemical gated. We also say ligand gated. Ligand means any chemical. Okay? We can say acetylcholine gated. We can say GABA gated. I mean, individual amino acids. Okay, then voltage gated. See, sodium was unable to go through, but read this membrane, voltage chain. Now it can go in. The channel opens. Now, just for your knowledge, but it's included in your course, the ion diameters, right? How big the ion is, like the lithium, sodium, potassium, rubidium, calcium, chloride, calcium. I mean, you should know these. I didn't put many, just the very important. And when water surrounds it, each ion, it becomes hydrated ion. Very big. These are non-hydrated. So this is the reason it becomes hydrated and sometimes getting difficulty. Okay. Resting membrane potential, again relation. Tell me any difficulty? It's very simple. I don't think you should just go home and check it. Now there are some of the important things. You understand what is action potential?
Yes.
Impulse or message. You understand?
Yes.
All the time when action potential is occurring, you cannot produce another action potential. It will end, then you can produce another potential. Okay? And maybe if you put very strong stimulus at a certain stage of repolarization, that is called as relative refractory. When sodium does not go into the cell, but potassium is going out, called as repolarization. Called as? Maybe at the end you can try with a very high level of stimulus. This is called as refractory. But when sodium is going into the cell, sodium channel are open, you cannot produce a second action potential. This period is called as absolute refractory period. Absolute means mutlaq. You understand mutlaq?
Yes.
The value of mutlaq. I mean kulliyatan. And relative. What you say in relative? تقابل تقابل مقابل تقابل صح relative ما شاء الله. And refractory period, action potential during which a new stimulus cannot be produced. The same thing. I mean, refractory period means when one action potential is occurring, you cannot produce another one. It will end or it will be at the ending stage. And inhibition of excitability, what it means? For example, you go to the doctor, you say you have pain of the arms, you like to bring out the tear. So he will give injection. What is this? It is an anesthetic. And when he puts an anesthetic, now sodium channel is blocked. Sodium cannot go. You don't find any pain. Why? Because there is no sodium channel is blocked. There is a case. I will not tell you the answer, but in the next class I will tell. I told you actually this, whatever. So you have experience. When you go doctor and you don't think that you have anything, anesthesia. Now it means excitability is inhibited. So this last line is very important to understand. One case is coming, so you have to think about it. Now change in membrane potential. I think you know the resting membrane potential, depolarization, hyperpolarization, shoot, and then repolarization, then hyperpolarization. Maybe I used the hyperpolarization wrong now. The resting wave potential, threshold potential, depolarization, and shoot. So that is upshoot, I mean the positive shoot, and then coming back repolarization, and then hyper-repolarization or hyperpolarization, again reciprocal. And see that all that is there, you can see that, and it's the same thing. Is anything additional? Just to let you know some another way. And sodium potassium pump. I think we discussed this story. You remember the people who are caught in the mountains? Who were they? Sodium. You don't remember?
Yes.
They went inside the protein. So chloride is gone. Chloride was unconscious, and they got contact, but they were not able to get contact until they had negative. And protein has negative. Protein has negative. And they did like this. Oh, sodium said, who is this? So dangerous enemy. So then, how the sodium got escaped, went out? Because potassium went down. Oh, good friend is, good friends, very nice, and never commit. So then he went out, huge negativity, because so many positive ions. Please, this is really very important. So many positive go out, negative. Protein does not need sodium, because protein has many other, maybe nicer than sodium. Protein likes other people, negative connection, and forget sodium. Now, who brings sodium to his home? Who brings sodium to his home? Because sodium in that area is very little. From low to higher is called as active transport. Who helped? Sodium pump. Sodium pump. Where he is located, sodium pump. When I say he, I'm joking, okay? Don't write he, just something. So he brings outside, but he lives, what is the residence of sodium pump? In the membrane. Okay, he lives in the membrane, but he sees what is happening. Sodium quickly catch sodium, little number of sodium, brings to the huge. So flow of some substance from its own lower concentration to its own higher concentration. Don't see there. The flow of a substance from its own lower concentration to its own lower through semi-permeable membrane using ATP. In passive transport, we didn't say using ATP. Yes. Using energy is called as active transport. Sodium pump, potassium pump. So see that sodium, potassium. Now this is a case. Remember, you went to a doctor, anesthesia. I think similarly, a 30-year-old woman noted palpitations. You know palpitation?
Yes.
Okay. And diaphoresis, perspiration. It is not written in your notes. Perspiration. Perspiration. You understand? Sweating. Sweat. Okay. You can write if you don't. And dizziness. Dizziness. After receiving an injection of local anesthesia, for what purpose? For a tooth extraction. Extraction means taking out. Now, in this case, you have to tell which phase of the action potential is correctly matching with it. You remember?
Resting?
Hyperpolarization.
Rest?
into the repolarization.
Okay, but now you think this is a question for the next class, you will tell me. But I told you the major anesthetic action is major on sodium channel, they are blocked. Sodium channel blocked means sodium ion cannot go into the cell. When sodium cannot go into the cell, what you say that state? But think. Now all these things, now you will think. Okay? Now we talked about action potential.
All of them.
And action potential travels. Is it a human? No. I'm joking. Action potential travels. Maybe 5 minutes more, really. Action potential travels. It's conducted. It's propagated from one place. Message. A risala is always, you send a risala to someone else, so it travels. Right? Risala means, message means it has to travel. So this is called as propagation. Is there any class, some teacher?
No.
We put a curtain. Okay, you don't understand my jokes, huh? So, otherwise, you do not put the input upon the professor. Our third thing is say someone is calling you. I'm joking. Okay, don't do that. I'm just joking. Because we are too much tired, you know. Huh? But don't do anything. I'm just joking. If you have taped my words, this is the reason I said that. Okay, so come back. All are non-phenomenal. When the sodium go into the cell, action potential will occur. You cannot stop it. It occurs. But if sodium ion does not go into the cell, action potential will not come. Will not occur. So all are non-phenomenal. Okay? But this all are non-phenomenal depend upon the axon diameter also. More axon, more velocity, more myelination, more conduction. You know that already. Right? And in unmyelinated axon, and this is very important point. I taught you in first year, but I don't think you remember. So, I remember I put something more. So, okay. See, this point is really very important. So, just revisions for some of you. This is one fiber. I mean, we don't put the axon, the neuron. This is the axon, but it is totally having the membrane, conductive membrane. You know conductive membrane? Conductor, muscle. And there is no hatches. There is another cell that has myelin sheath. This is this is hatches, this is conductor. So current will jump from the node to node, conductor to conductor. So when it will jump, the speed will become very fast. But when it will not jump, it is conductor. There is no insulator. It will go slowly with the same speed, like this. Now see, this will go fast. So myelinate, I'm talking with you with the myelinated fibers, okay? Because we do fast movement, eye movement, face movement, hand movement. But when we do some function slowly, it occurs with unmyelinated. Did you get it or not? Okay, so unmyelinated axon relatively slow, or around 1 meter per second because small, and myelinated axon relatively 10 to 120 meters fast. Why you got it? Larger. Their size is larger because they are myelinated. What is myelin? It is a white colored fats, lipids. And lipids are insulated. Hatches. Am I right? The current cannot pass through it. So what happens? Current will not go through like this way. It will conductor to conductor. This is conductor. Why it is conductor? Because there is no myelin sheet here. Myelin sheet has with interruptions. So this is myelin sheet to current, conductor to conductor. This jumping, it is called as saltatory conduction. What we call? You have studied, I think. Saltatory conduction. Saltatory conduction. Saltatory conduction means node to node to node. So this is the area node, this node of Renvier, where huge number of sodium channels are present. You know that? This is the area where whole neuron, the density of sodium channel is more in node of Renvier. Node of Renvier. Node, you can say node. Renvier is scientist name. It will come, don't worry. It will come in your notes.
This is the reason that the most sensitive part is this part. When the neuron, this is the neuron, and where axon begins, in this area, the node afferent where, why it gets stimulated quickly, most quickly? Because huge number of sodium. And sodium channel means more excitability. Are you getting or not?
Yes.
More excitability. Now your other case relates to this point. I told you the answer actually. Now this is up to you, you understand or not. But okay, propagation is easy. Saltatory conduction, I told you. There is no saltatory conduction in the unmyelinated. Is it clear? Is it anything that you do not understand, please? Because things are just revision. This part is very easy. Propagation, simple. Case. Now I told you. You remember, this is the part where most sodium ion channels are present. It is most sensitive, most excitable. Is it okay? Now considering this, listen this case. A 14-year girl was suffering from frequent episodes of red, painful, warm extremities. Extremities, these are extremities, legs and extremities. So she was diagnosed by the physician as having primary erythromelalgia. So now see, this definition is given, but it is not given in your notes. You can see from dictionary, and this is not included in your notes, okay? Just for your knowledge, what it is, when your vessels dilate, too much dilate, and all the details, mostly in the feet and sometimes in the arms also, when they dilate. So it's a vascular problem. Now the question is that maybe, but if it is primary type, usually the mutation of the sodium channel occurs. Mutation of the sodium channel is a protein. Sodium channel is a, so mutation, you understand mutation?
Yes.
Part, a little part, amino acids are changed. So this disease occurs, and this is the primary form. Now the question is that which part of the neuron having highest concentration of sodium channels might be involved? Dendrites, axonal membrane, undermyelin, node afferent where? Unfortunately, I told you. Initial segment, a cell body near dendrites.
No.
Why? Because node has huge number of sodium channels. So definitely it will be the most excitable part of the whole, soma. Okay? Is it clear? But you think and tell me, maybe I'm wrong. You know? Next time I will ask again. So propagation, I think if you inject local anesthesia, what was the result? No. Excitation or inhibition? Inhibition. Okay, it means the sodium channels are inhibited. Okay? They are not excited. Sodium channels are excited or inhibited by local anesthesia. Inhibited. This is the reason no more action potential occurs. When you do not feel, it means that action potential is not traveling. You understand? When you do not feel it, you take the injection of anesthesia, local anesthesia, and you do not find where is this, you do not find any pain. If you cut it, you will not find a doctor. Okay? You say my teacher told. So the reason is that action potential is not traveling in these areas. Why it is not traveling? Because sodium channels are closed. Sodium channel closed means the membrane is closed, message is not going. Guarded or not? Okay. Number 2, potassium ion concentration. Okay, see, it affects the resting membrane potential. You know, and necessity depolarization, and it decreases the excitability. For example, in the blood, potassium is decreased, then the action potential will be influenced. So it means potassium is very important. If it is 5 to 10, whatever. If it decreases, if it decreases, the changes will occur. Extracellular and intracellular concentration will be changed. Okay? Are you not getting that baby joke? Something important. Did you understand or not? So hypokalemia. Who is kalemia? What is kalemia? Okay, right? So if hypokalemia occurs, excitability will increase or decrease? Decrease. You are not understanding. Okay. Decrease means you will go more toward positivity. Because points are we are losing. So it means negativity minus 70, minus 80 is very important.
membrane negativity will change. It means excitability will decrease. Number 3, when the myelin sheath is lost, you know there are some diseases.
Multiple sclerosis.
Who said? Multiple sclerosis, yes. In multiple sclerosis, the major cause is myelin. This myelin is lost. Oh. And this is very important. Now, how the cell-tate reconduction will occur? Problem.
Slowly.
The person will work like this, like this. When he will talk, cannot move because there is no myelinated fibers. If many myelin fibers are gone, very dangerous. So this is degenerative disorder and CNS multiple sclerosis. Similarly, PNS, Guillain-Barré syndrome. It's written on one line, but this line is not included in your course. It's written the muscle weakness. This disease is the muscle weakness due to the weakness in the immune system. Okay, I didn't go in detail, but just the definition. And hence damage occurs in the peripheral nervous system. So peripheral nervous system damage occurs because of the immune system, the problem in immune system, and this is because of muscle weakness. And this disease occurs. And treatment of multiple sclerosis include, there are names of some drugs. But what is multiple sclerosis? Tell me again, please. Demyelinating. See, one word, single word. That's demyelinating. I mean, the myelin is lipid, but lipid is also important. Insulators are also important. How the current will, will go make the cell-tate reconduction. So, cell-tate reconduction will be good. Okay, now this case.
Same.
No, same case. There was no case, there was another case. I think I told you, right? Okay, there, two really. Okay, so the lecture is almost finished. It's just repetition, just to remind you that next time you have to answer on this, okay? And then one more minute. Summary. What we studied. I think you should discuss a little bit. It's a interactive lecture. What we studied, can you tell? Number 1, axonal transport. Is it clear? Yes. It was interesting. I hope you will apply in medicine, inshallah. Because there are a large number of viral diseases, many problems, and physiological processes that from the brain, some important things go into the body.